continue with section 7.2, and if you look up here on the board, we're going to go ahead and complete this problem. It says find the volume of the solid formed by revolving the region bounded by f of x equals 2 minus x squared and g of x equals 1 about the line y equals 1. Okay, so basically what they're saying is that I'm going to revolve this about the line y equals 1. So if I spin this around, if I look at this, what am I going to end up with if I spin that around?
A circle.
Kind of like a ball, right? But then the ends are more like a football. Okay, kind of be like a, squished football is what's going to happen when you revolve it around that line. So there's going to be no holes. It's actually going to be a solid since I'm revolving about that line. So from yesterday we learned that how we find that is we take pi times the integral from a to b, remember, of r squared, and then times the width of the disk. And so first of all, let's go ahead and talk a little bit about what we have, okay? I first of all need to figure out what my height of my disk here is going to be. I need to figure out what that is going to be. Okay. Now if I think about things, at 2 minus x squared, this is my value right here, all the way from top to bottom. Okay, that's actually what 2 minus x squared is. But I don't want that. I want this representative disk that's only the yellow. So really, what am I doing with my f of x value in order to get that yellow disk? Cutting in half. Okay, yeah, kind of. Not necessarily half, because, right, what am I cutting off every time I draw a disk in? Because really what I'm getting, if you can't see it right now, what I'm getting each time is I'm getting this value right here, and this value right here, and this value right here, and this value right here. So notice what I'm cutting off. What am I cutting off here every time?
1.
1.
I just thought it did.
I'm cutting off 1 every time, right? So if my value here was 1.5, the height of my disk is going to be 0.5. If my height here is like 1.7, I'm cutting off 1, it's actually going to be 0.7, okay? And so really what I need to do is take off 1 every time. And that will be how high my disk is, okay? That will be the radius. And so if I calculate that, I end up getting what? What will this simplify to be? 1 minus x squared. And so now let's go ahead and find the volume. So the volume equals pi.
Do you always subtract g of x from f?
It depends. In this case, yes. But there will be a time when it's not, and that's when we get to the washer method, and we'll talk about that. So pi, what am I going to integrate from? -1 to +1. Now the radius will be
2 minus x squared.
1 minus x squared, because that's what we found it to be, squared. And then the width of each disk is going to be dx. So now what I need to go ahead and do is I need to go ahead and FOIL that out. Okay, so if I FOIL that out, I really get 1 minus 2x squared plus x to the 4th. So let's go ahead and integrate that. What's the integral of 1? X. What's the integral of 2x squared? 2x cubed over 3. What's the integral of x to the 4th? X to the 5th over 5. And I'm going to evaluate that from 1 to -1. Okay. So I just need to go ahead and plug those values in, both 1 and -1, and then I'll be able to find out what the volume is.
So this is what we did yesterday?
Yeah. So really you should get 1 minus 2/3 plus 1/5, and then minus -1 plus 2/3 minus 1/5.
So 2/15.
What, 2/15 is the first one, this one?
I got 8.
Well, did you get 6/15 here? This should be 8/15,
I got negative 8/15.
and that one should be negative 8/15. So your answer should actually be 16/15 pi, or 16 pi over 15. All right. So now what we're going to do is we're going to talk about how you find the volume of a donut. Okay, and how you find the volume of a donut is called the washer method. And why do we call it the washer method?
It looks like water.
It looks like a washer. Okay, when you have those washers that you put with like the nuts and the bolts, you put a washer on, this is essentially what we're cutting into. We're cutting the figure into washers. And so the only difference here is that we've got an outer radius that we call big R. Okay, so that's your big R. This is your outer radius. Now this is different than the problem we just looked at. Okay, this is different because there's a hole in the middle. When there's a hole in the middle, this is the way you have to approach this problem. Okay, and so you've got your big radius, and you're going to subtract from that your inner radius right here. Notice you square each of them first before you subtract them. So that's what's different in the previous problem that we looked at. Okay, main difference is because there's a hole in the middle. So we take the big radius squared minus the little radius squared. And that should make sense because you're finding the volume of the big minus the volume of the middle. Okay, so let's go and look at an example of that. Okay, find the volume of the solid formed by revolving the region bounded by the graphs of y equals root x and y equals x squared about the x-axis. And so what we need to do when we graph these, notice it doesn't give us any values of x that we use. And so that's why when we graph these, we are looking for intersection points. And so notice in our figure here, we already have 2 intersection points. And so this is the values we're going to use, those 2 values on the end. So this is a prime example of a washer method because it's going to have a hole. So to find the volume, pi, what am I going to integrate from? 0 to 1. So when you have to do this and it doesn't give you a figure, you need to graph, find where they intersect. Okay. Now in this case, I've got big R. So that's my big radius. So that would be this one right here. What one will that be?
X, or root x.
Root x quantity squared minus the little one, which is what?
X squared.
X squared quantity squared times dx. So now all I need to do is calculate this. It isn't any more difficult than the ones we looked at yesterday. It's just got an extra step. So I'm going to integrate from 0 to 1, x minus x to the 4th dx. Integral of x is x squared over 2. And the integral of x to the 4th is x to the 5th over 5 from 1 to 0. So then now when I plug in 1 and 0, let's plug in 1 first of all. When I plug in 1, I get 1/2 minus 1/5, which is 3/10, and then minus 0. So your answer will really be 3 pi over 10.
So how do you know when to use the washer method?
What?
How do you know when to use the washer
It's got a
method?
hole.
When it's got a hole when you revolve it, yes.
You can totally look at that thing. It's got a hole. It's got a huge hole.
So now we've covered the last example. We are going to spend some more time on the disk method when we next have class. We'll probably do a worksheet on that as well. And then we're going to talk about something known as the shell method. Okay, the shell method is actually about creating shells as opposed to like disks and washers. Okay, so you were given your assignment yesterday. It's found on page 463. Okay, 1 through 3, 5 through 8, 11, 13, 15, 16, 19, and 20.